No sign of any pizza.
I know.
If they do,
I've put in an extra 15-minute break between the first and second speakers because
Okay.
Eunice thinks they should be here around 6:45.
okay. The guy said they will send if it comes,
Yeah.
they'll send them up, but I'll wait out here.
Thanks. All right. I think that is most people. So we're going to kick off. First of all, I apologize for lack of pizza. This is probably only the third time in 7 years that the pizza has not showed up on time. So I know everyone is feeling a bit hungry. They said they will be here by 6:45. So we're going to add in a little extra break between the first and second speaker, and hopefully everyone can go and grab some pizza when it arrives. But I apologize. Not the best start to the new year, but that's life. That's how it is. Okay, so welcome to Cloud Native London. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies based in London. I am your host, Cheryl. I am online at ocheryl.com. I'm a senior director at Arm, where I work on Arm in servers and data centers. Previously Google and Apple, and also CNCF. Today, we're going to have our first speaker, Meryem, who's going to talk to us about navigating LLM deployment, tips, tricks, and techniques. Then we're going to have a pizza break, hopefully, at 7:15. We're going to push back the second talk slightly to 7:30, which is Platform Engineering Untold Truths. Is it just an infrastructure matter? By Graziano and Rhea. And then 8 o'clock, we will head to the pub. We will go to the Conductor, which is just outside this building, just in front of you on the left. And then hopefully everyone will keep chatting for the rest of the evening. Some live polling, so questions about you. If you've got your phone, please just scan that QR code. You don't need to download anything. It's going to take you to a service called Poll Everywhere. You can just put your name, you can skip, and we're going to do a couple of questions about you and about how you use Cloud Native. You can have that QR code at the top if you missed it. Is this your first time at Cloud Native London? So you should have a yes or no button. And I think everybody's getting the hang of it already. Looks like yes, first timers are just edging out. 60, increasing. We're also live streaming to YouTube and to Twitch this evening. So there will be a few people at home who can join us on this live polls. The no's are starting to pick up again. We hit 50-50. Who's going to be the tiebreaker? Maybe we've landed exactly on 50-50 first timers and returning people. So, first timers just come out of the top. Okay, let's go next question. What's your job title? Pick whatever's closest to what you do. Your options here are architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security engineer, or anything else. Looks like the anything else's are showing up quite strong today. Usually we have a pretty good mix of people. And the others are 50%. That is probably the highest I've ever seen them. So please do come and introduce yourself if you put yourself as an other. Okay, let's go to questions from our speakers. Are you building AI with open source models? Yes, with only open source. Yes, some. No, only proprietary models like GPT-4. Or no, we're not using AI at all. hopefully Meryem is here and online. Meryem, can you hear me? Let me see if Meryem is joining us. She's not on here. Okay, well, interesting. So looks like yes, some is ahead. So 50% of people saying that we're building AI with some open source models. So a mix. Okay, let's move on. What does circular economy mean in the context of platforms? Is it the subscription type used by the vendor? Is it the method of applying platform engineering to the financial world? Or is it a way to foster collaboration within the platform, aiming to maximize the ROI of the platform? Give you a moment to think about this one. And then, okay, so our speakers are over here. So Graziano, looks like, well, everybody's agreeing on the third option. Is that correct?
No, guys, it's obviously the second option is a method to apply platform engineering to the financial world, of course. No, I'm joking, is the third option, the right one. And so we will later see how to apply these methodologies, this culture of circular economy of software inside your platform.
All right, very interesting. So I want to thank everybody for joining in our live polling. Please keep it open on your phone because we'll do Q&A with the live poll as well. Somebody changed their answer at the last moment. Okay, I need a selfie for social media. So everybody just hold on. Please wait for time. Really happy. Okay, big wave, big smile. Thank you very much. If you want to come and speak here, cloudnativelund.com. The next speaking slots are available in June. You can also sponsor us and help pay for some of the pizza that will arrive later. Or you can promote your own events with us as well. And that is it for me. So I think, yes, Meryem has actually joined now. So I'm going to stop sharing my screen. And Meryem, are you happy to just get going? Okay. You are currently muted. So.
Okay. Can you hear me now?
Yes. Okay, over to you. Thank you very much.
Fantastic. Okay. Can you all see my screen?
See it.
Fantastic. So, hello, I'm going to give the talk that I gave at QCon. I gave it twice last year. So I gave it once at QCon in London in April, and I gave it again in San Francisco in November. And in that 6-month period, a lot had changed. So this is the latest version from November/December. And I'm going to be talking about LLM deployment and how you can navigate that so it goes smoothly for you. So I could have also named this session How to Deploy LLMs if you don't work at Meta, OpenAI, Google, etc. Essentially, this is a session for people who want to deploy LLMs or open source LLMs in their own private environment, self-host, and they're doing it in a normal enterprise setting. So out of this session, you're going to get 3 things. So firstly, you'll be able to figure out how to evaluate when self-hosting is right for you. We'll be able to understand the differences between your deployments and what deployments look like at AI labs. And then I'm also going to talk about best practices for self-hosted AI deployments in kind of corporate and enterprise environments as well. But first, hello, I'm Meryem. I'm the co-founder and CEO of TitanML. At TitanML, we build infrastructure for efficient, scalable, and LLM deployment. You can kind of think of it as a deploy your own Bedrock or model garden. And we specialize in on-premise and VPC AI deployments. That QR code links, I believe, to my LinkedIn. So if you want to connect, feel free to scan. So let's start with evaluating when self-hosting is right for you. Firstly, what is self-hosting? So most people who are interacting with AI are familiar with API-hosted language models. So you might, if you've used OpenAI or Anthropic or anything like that, you might be used to that, which is you essentially send an API to a third-party environment. In this case, maybe it's the OpenAI environment, who host their models on their GPUs. And your application essentially calls out into their environment to do that. Self-hosting is a very similar setup, except the models and the GPUs are yours, or maybe rented. So a model that you're in control of sits on a GPU that you're also in control of. So this could be that it's all in maybe your AWS environment. It could be that it's actually in an on-prem environment, or it could be in it's wherever else you have GPUs. But self-hosting just means you have control over your data and your models and your inference. And why would you ever want to self-host? Well, there's broadly 3 reasons. The first reason why you might want to self-host is when you're deploying at scale, there's much decreased costs. So the way that these API providers charge is they charge per token, which in the early days is very, very cheap. But as you start to scale, actually it ends up being very, very expensive. When you're self-hosting, you're able to drive a lot of efficiencies that mean once you're at a sufficient scale, it's much, much, much cheaper to self-host. There's also improved performance for self-hosting. So if you're doing a task that's maybe domain specific, so in the biology industry or finance industry, you can often get much better performance if you're using self-hosted models. And also the state-of-the-art models that have been released over the last year are on par, if not better, than some of the ones that are available by APIs. So you can actually deploy better applications. And finally, privacy and security. So a lot of our clients aren't able to send data to third-party environments. They need to deploy in their own environment. And self-hosting means you're able to leverage AI, but don't have to go through legal and compliance every time you want to do something new. So I can also, this also links directly with some research that has been done by A16Z, which is a VC out in California. So the 3 main reasons why enterprises say they care about open source is control, customizability, and cost. So that goes directly to the privacy, the performance, and the cost aspect we discussed earlier. And that's also why most enterprises are expecting to increase the amount of open source they're using. So 82% of enterprises either use mainly open source or expect to switch when open source matches performance, which actually happened last year. I'm going to make a quick detour as well, that you should always self-host your embedding models. And the reason for that is because it's the kind of thing that's easy to self-host, but also no one wants to be in a situation where your API provider deprecates these embedding models. But that's a public service announcement. If you're interested in that, you can message me afterwards. So, good reasons to self-host. If you're building for scale, if you need to deploy in your environment, if you need to use embedding models or re-ranker models, or you're building some kind of RAG, if you have maybe domain-specific use cases, or if you have trust issues, maybe someone hurt you in the past, they're good reasons to self-host. Bad reasons to self-host is you thought it was going to be easier. It's not necessarily easier. And someone told you it was cool. Also bad reason to self-host. So if the things on the left might be true for you, then this talk might continue to be interesting. So let's understand briefly as well the differences between your deployments and the deployments of AI models at AI labs like Meta and OpenAI. So when we're self-hosting, that means we need to serve these models. So we go from having it being deployed on their GPUs and their stack in the way that they're controlling to suddenly we're in charge of that deployment process. That's a lot that we've got to make sure we can maintain. But self-hosting is different to the API labs. So when I'm Meta or Google, I have lots and lots of money. I have lots and lots of H100s that I can deploy big models at scale. I'm more likely to be compute bound as well. And I have little information about my workload. So if I'm OpenAI and I'm hosting GPT-4 on my infrastructure, I don't know if I'm going to get a lot of short prompts but long responses, or if I'm going to have long prompts and short responses. I don't actually know any of that information. And another difference is that I'm optimizing for one or two models. So if you look at OpenAI, they have maybe they have like GPT-4, they have like O1 and now like O3. They're not actually deploying that many models. That's probably not going to be the case if you're deploying in your own environment. You're probably going to be dealing with far many more models. So in your environment, you're probably going to be dealing with cheaper, smaller, more legacy GPUs. You're more likely to be memory bound as well. And you have lots and lots of information about the workload. So because you're deploying it, you know what your end applications look like. So you know if you're deploying things that look like RAGs, you know if you're deploying things that look like classifiers, you can use that to your advantage. And you're also probably going to be deploying dozens of model types, especially if you are using self-hosting to be able to get better performance. Using things like fine-tuned models and specialized models mean that you have to be able to adapt for this broader menagerie of models. So the deployments that you're going to be doing if you're self-hosting is very, very different to the deployments you'll be doing if you're at one of these companies. And we spend most of our time thinking about deployments in this kind of environment rather than in this kind of environment. So that's what I'm going to be talking about next. So some of the best practices for self-hosted AI deployments in corporate and enterprise settings. And I'm going to give you a couple tips for self-hosting LLMs, and I'll go through them one by one. So these are the tips. Oh, it's actually 6 tips. Feel free to take a picture now, but I think I'll also have at the end. The tips are know deployment boundaries and work backwards. Quantize models are your friends. Getting batching right matters. Optimize for your workload. Be sensible about models you use and consolidate infrastructure within your organization. So these are broadly my tips for self-hosting LLMs in non-big tech environments. So let's start with the first one. Know your deployment boundaries and work backwards. So assuming you don't have unlimited compute, which most businesses don't. So if I'm Meta, I have like unlimited H100s that I have access to, which is great. But most enterprises, maybe you're working with some, G5 instances on AWS. So because of that, because I have a limited compute budget that I can use, I have to think about that when I'm doing my building and my deployment. So I would like to know before I think about my deployment, what kind of available hardware do I have? This is especially the case if I'm actually on-prem. Do I have target latencies that I want to hit? So maybe I'm dealing with a real-time chat application and I need my latencies to be below X milliseconds. Or maybe I'm actually doing something that can be batched and run overnight. That's really good for me to know. It's also good for me to know things like expected load. So am I expecting to deal with something where I'll have consistently X many concurrent users? Am I going to have a really spiky workload? All of these things are things that I should know about before I think about my deployment. So if I can formulate something like a sentence, ideally I would like to deploy on an instance cheaper than X and would be able to serve Y concurrent users with latency of less than Z, then I would have already thought about my deployment boundaries a lot more than most people do. So if I have my deployment boundaries, the next tip that I would have is that you should almost always use quantized models if you're serving open source models. So quantized models are essentially, you can think of them as like compressed versions of larger models. And quite often when people think about quantization and compression of language models, they often think about what you lose. So you often say, okay, well, I've taken this model that's 70 billion parameters and I've, quantized it down to int4, let's say. What accuracy have I lost? I think that's the wrong way to look at it. I don't think you should look at it as what accuracy have I lost, but I actually think you should think of it as what accuracy have I gained versus a model of that size natively. And I'm going to reference this paper by Tim Detmers, which is called The Case for 4-bit precision. And essentially what this paper argues is that for fixed resource, so for fixed model bits, the accuracy is far, far higher if I use a model that has been compressed down to that size rather than a model of full precision of that size. So let me take this graph. So let's look at the red line, which is in FP16, and then let's look at the orange line, which is in 4-bit. So let's take a fixed point. So let's say 10 to the 11 bits. You can see that the accuracy is far higher consistently across almost all sizes for the model that's been compressed down to that bit size rather than the model that was more natively in that size. So the way to think of it is not if I compress this model, what's the accuracy I lose? So maybe I'll go from like here to here, for instance, if I compress it. But actually, I've managed to gain much better. I managed to deploy a better model by using a compressed model. So this is why we almost always recommend using quantized models if we're deploying. Neuromagic also did some great work on this as well. So here we have that actually, what this graph is showing is that actually for modern forms of quantization, you actually don't lose that much accuracy as well, which is very, very impressive. So, and this is on the y-axis, you see accuracy recovery, and you can see that if they do lose accuracy, they don't lose no more than like a percentage point or 2. Here's some more research from that same Neuromagic article. I think you can find it online, which also argues that quantization on the whole is a very, very good thing, and that the accuracy loss, if any, they show that there actually isn't very much, is almost always worth the trade-off. So if I go back to my point 1, which is you should figure out your deployment boundaries, you can then work backwards and figure out what model you should deploy from that. So this is using a slightly old example of Mixtral, which was good in like end of 23, beginning of 24, but is no longer good, but the point still holds. If I have figured out what my deployment boundaries are, maybe I know the instance I want to be deploying on, I can figure out the amount of memory that has, and then figure out what the best model, when quantized down, I can deploy on that. So I could deploy a Llama 13B that's like natively that size. I can't deploy a Mixtral, which at the time was better than Llama 13B, but I can deploy a Mixtral 4-bit. So I can deploy this compressed version of the Mixtral model down, which actually is better performing than the original Llama 13 billion. So if in doubt, always pick the biggest model when compressed to 4-bit that you can fit on that resource. But if you're looking for quantized models to deploy, both the Bloke and TitanML's Hugging Face page have these readily available, so you can play around with these. The third tip that I'm going to talk about is batching strategies. So this is something that we see people getting wrong all the time. We see it makes a big, big difference to get batching right. So the first thing when people are deploying language models that they might implement is no batching, which is like the most basic V0, which essentially you process the requests one by one. And then the GPUs are very, very expensive and you get very, very poor GPU utilization. So you're not batching anything at all. Not great. And the second thing that people try, which is probably the most common thing that we see, is they've tried something like dynamic batching. So this is when you wait between requests and then you group them and then you process the groups. And then it will run the inference either when like a set batch size is achieved, so it's got that many requests, or after a set period of time. And what you get here is you get really, really spiky GPU utilization, which is not great either. What we recommend, so especially if you're deploying LLM models or generative LLM models, doing something like continuous batching means you get consistently high GPU utilization. So this is a state-of-the-art batching technique designed for generative models. It essentially lets incoming requests interrupt long in-flight requests in order to keep that utilization very, very high. So the batching is done almost at the token level rather than the request level. And you get a slight per token latency hit, but it's normally massively worth it for the throughput improvement, and I get much better utilization of my GPU throughout. So that tip number 3 is your batching strategies. Get your batching strategies right for LLMs, and for LLMs, that batching strategy is continuous batching. The 4th tip that I have is workload optimizations. So something that's exciting is that one advantage that you have when you're deploying LLMs versus something like OpenAI or AWS Bedrock or anything like that is you know something that they don't know, which is what your workload actually is. And because you know your workload, you can make a bunch of optimizations that are specific to that workload. So I'm going to talk about a couple techniques that you can implement if you know what your workload looks like, that it would never make sense for someone like OpenAI to implement it the same way. So one of these examples is prefix caching. So to speed up the prefill of long LLM inputs, so this is in the instance that you know your workload is long prompts. You can pre-compute the KV cache of text and then reuse the KV cache when the context is reused as the prefix of another LLM input. So a case where this would be really, really valuable is if I'm doing some kind of long context RAG. Let's say I have a very long document that I'm constantly doing RAG off of, and actually the question that's changing is a very small part of that overall document or that overall prompt. I can essentially cache that the bit that's repeated throughout requests and then just process new the bit that's changing. So long context RAG, it's really useful for long document query. It's very useful for multi-round long conversations. It's also very useful for, and on average, we record about a 7x higher throughput. And you can see that on the graph here. So it is, in this instance, I can compare the light green line and then the light green line and then the light blue line. And then on the y-axis, I have the throughput. And then on the x-axis, I have the batch size. And you can see a significantly improved throughput by implementing techniques like prefix caching, which is something you can do when you know what the workload will look like. There are other forms of caching as well. So speculative decoding essentially is a way of caching, such that the model can mass predict tokens if they're the same as what the model might have generated before. The use case for this is any task where the model might be generating similar tokens between requests, which happens all of the time in enterprise use cases. So for example, we had a use case where we saw a 2.5x latency decrease for a JSON extractive workload. This is the kind of thing that only makes sense if you know what your workload looks like, and it only makes sense in a single tenant environment where I'm only dealing with the same kinds of applications. So my 5th tip, so far I've done know your deployment boundaries, always quantize, batching strategies are important, and knowing your workload can make a very big difference to deployment. Number 5 is model selection. So this was the most popular slide from both my April talk and my November talk from KubeCon, which is GPT-4 is king, but you don't get the king to do the dishes. I can probably update that now with GPT-03 is king or GPT-1 is king, 01 is king. But essentially the purpose of the slide is to say, most people, when they're building enterprise use cases, are often using models that are much better than they need to be for the task that they want to be doing. So there's lots of parts to, for example, an enterprise RAG or an agent pipeline that don't need GPT-4 level reasoning. So for example, let's say I'm doing some kind of classification task. probably don't need, a model that's as smart as a STEM graduate. So when you can, you should always use models that are smaller, cheaper, and easier to manage. This will just make your life much, much easier. The Gemma and small llama models are a really, really great place to start. So for example, the small llama models, I mean, the llama 8 billion is as good as GPT-4, but much, much smaller. And then there are also smaller variants of llama, which are very deployable even on CPU, which is where we would recommend to start. So think about your workload, think about whether you're using, overkilling with the models that you're using, because you'll find it much easier to deploy them if you're not deploying them on not deploying like the king of the AI models. And the final thing I'm going to talk about is infrastructure consolidation. So in traditional ML, most teams unfortunately work in silos, and that doesn't work with Gen AI. So Gen AI requires consolidated infrastructure. And the reason why is because Gen AI is computationally much, much more expensive than traditional ML. So what we recommend always is to centralize deployments once, maintain them centrally, and then provide that as a shared resource across organizations. And it enables those developers to call on that central infrastructure and focus on the application that they're building. So serving is really hard. You shouldn't do it twice. And GPUs are very, very expensive, so you shouldn't waste them. You should keep them as utilized as you can. So if I think of what a good architecture looks like for a central compute infrastructure is, for example, I might decide as a business, I'm going to have a couple approved models that I can serve. So, this is a bit old, but, I wouldn't deploy Mixtral anymore. But maybe I've decided that I'm going to deploy, between 3 and 5 models that we think are good enough for most use cases. And then I provide those APIs. My downstream teams can then work with this to build RAG applications, and they can fine-tune these central models using LoRa's and be able to deploy just those LoRa's rather than the whole infrastructure. So I can enable hundreds and hundreds of applications off of this central compute infrastructure. If you've seen AWS Bedrock, what we're almost suggesting is that you should reproduce an AWS Bedrock type service, but completely private and bespoke and only with the models that you care about. So I can give you an example of a client that we worked with, Arora. So they had a situation where they had a bunch of apps and a bunch of models serving those apps all deployed on GPUs. What we're able to do is consolidate that infrastructure and just deploy it on half the number of GPUs, for example, because the apps were then able to share that same resource. So we've got reduced inference cost, we've got much higher GPU utilization, centralized serving and management made it much, much easier to do all of that process. And you also get much easier development at the end of the day. And it means when I want to deploy app 5, I don't need to go through a process of deployment. I can just call that same API endpoint. So you can do this. Maybe you'll have an LLM large, a medium, a small, an embedding model just to start with as like a starter pack for like an internal model garden. And then you can allow your downstream developers to call on that. So here's my 6 non-exhaustive tips for self-hosting LLMs. You should know your deployment boundaries and work backwards. Quantized models are your friends, so try and use them. And the TitanML Hugging Face page has these available open source. Getting batching right really matters. Optimize for your workload. Be sensible about the models you use and consolidate infrastructure within your organization when you can. So what I've talked about in this session is when self-hosting is right for you. So if you care about one of scalability, privacy and control, or performance, understanding the difference between your deployments and deployments of AI labs. And the biggest deployment is you're not working with infinite resources and you know your workloads. And then I've given you 3 examples of best practices that we've come across over the last 2 or 3 years or so in the space. Any questions? I'll pause there.
Hello, thank you very much for your talk. So I'm going to just take over the slide for a moment. Okay. Any questions, please type them here, or you can also use the orange cube. Questions. I don't want to throw it that far. You're gonna have to pass it back. Okay, ready? Just pass it back.
My question is actually, thank you very much for the talk, which was quite healthy, actually. My question was about the sharing of resources, GPU resources per application. My issues here about latency. My second question is about the alternatives. We know one company just controls GPU algorithms at this moment in time. Have you ever considered running risk on AIs, risk-based platforms like Hewlett Packard's precision architecture, IBM's Power, or Oracle's Spark? The algorithms, the registers are not dissimilar with the GPUs offered by this singular vendor. Thank you.
So just so I understand the first question, was the first question about optimizing for latency?
Yes, or make consolidated applications for latency. I mean, if applications start sharing threads from same GPU, there are going to be bound to be issues with latency. I mean, like any other processing unit as well. How do you handle that? And secondly, I have two questions. Secondly, what's the alternative to GPUs? I personally consider risk-based architectures as a viable alternative and cheaper alternative to GPUs.
Yeah, thank you so much for the question. It's a very good question. So I'll take the first question about how do you optimize for latency. And there's a couple ways that you can optimize for latency. And one way is that you can just buy way more GPUs and have them, spend a lot of money there. We tend to focus more on software approaches on how you can optimize latency. Well, firstly, because it's cheaper, and also because we think it's the right thing to do and means you can actually run more stuff. So the difference between running an LLM on a GPU, just like, in a naive way, like Rapid and Fast API or whatever, and doing it in an optimized inference server can be multiple orders of magnitude difference in terms of latency. And the difference there is the software that you're deploying. And there's loads of different techniques that you can do to make your latency far, 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 far better. So I talked about two of them in the talk, which is, various forms of caching that you can use. There's also things like flash attention and optimized CUDA kernels. And I could do a whole talk on how can you optimize latency. But I think the key thing that I would highlight is you can get very, very fast latency, even on legacy GPUs, by building with an optimized software stack. The second question, I think, was around what are the alternatives to GPUs? So we spend a lot of time thinking about this because a lot of our clients use us in order to avoid the hardware lock-in of one big dominant provider who may be telling them they need, a bunch of H100s or B100s to be able to run their AI workloads. We fundamentally disagree with this. We think for most enterprise use cases, you don't need the latest generation GPUs. You can run on legacy GPUs. You can run on cheaper instances. You can even run on consumer grade GPUs if you want to. So that's one thing of how can we utilize the cheaper GPUs that already exist that maybe your organization has already bought before we have to consider upgrading. We also need to consider, well, do I want to build my software stack in a way that can only handle NVIDIA? And the answer for most enterprises is no. I don't want to just build my data center off NVIDIA because maybe one day I'll want to buy AMD, or maybe one day Intel might, release a good GPU that I want to deploy. So for us, we build our software stack so that it serves NVIDIA, AMD, and Intel, both CPUs and GPUs as well. So it gives you that choice. So you can deploy on CPU or legacy GPU for your small models, and then deploy on AMD if you need to, or deploy on whatever GPUs are most relevant. So we're still in the traditional hardware of CPUs and GPUs. I don't know as much about the other things that you mentioned though.
Well, thank you. The other things I mentioned about was risk-based systems. That's all that's computing themselves, client-server computing. I mean, IBM has them, Hewlett-Packard has them. The problem Hewlett-Packard has is that a lot of their developers on the risk-based platforms have moved over to NVIDIA, and they've lost them. The same thing is happening with Oracle's acquisition of Sun Microsystems with Spark. The algorithms for the CPUs with NVIDIA are actually the same, even faster and cheaper. But for some reason, there's been a gang up to allow NVIDIA just, through the GPUs at whatever prices they want. Thank you, anyway.
Thank you.
Cheers.
Thank you. You can bring it back. So the first question submitted from the audience. So how would you compare the deployment complexity between self-hosting a simple app, e.g. a web app, versus self-hosting an LLM?
Oh, such a good question. It can really depend. So self-hosting an LLM is is a big spectrum. So on the one end, I could have the complete DIY solution where I build it all myself, where, I'm building my inference server, I'm writing my CUDA kernels all myself, which is essentially what our company does. That's what our company does. And that's a big job. That's an entire team or an entire company's job. All the way to I'm using software packages that allow me to deploy LLMs. So an open source option that's really good if you're deploying like on your laptop is Ollama. If you're deploying an enterprise setting, like TitanML is very, very good. And that makes it pretty much as easy as using an API service. And there's kind of all these things in between. So all the way from full software stack to be able to, self-host LLMs within your environment, all the way to complete DIYing, in which case, you're spending millions and millions of dollars to build that stack. So if you're using a service, it's much easier than like self-hosting a web app or on that same order of magnitude.
Okay, next question. What is the difference in costs to AWS hosting versus Bedrock?
Okay. So Bedrock hosting, if you're using like the naive, like easy entry point, is hosted on a per token basis. So if you're just doing like a couple like POCs or experiments, it's very, very cheap to do that. If you want to use fine-tune models, often you have to do reserved instances, in which case that's basically the same price as self-hosting. So self-hosting when you're at scale is much, much cheaper than using Bedrock. And it's much cheaper, especially if you want to do any kind of like fine-tuning. One thing I would also note if you're using Bedrock is I think only about 38% of the models they say are advertised in Bedrock are available in the EU region. So that's something you should check out as well. But Bedrock's a really good entry point, especially if you're doing like POC work or like doing my very first LLM app before maybe you're getting to mass scale production. Or maybe you might want to think about self-hosting as well if you've got a multi-cloud strategy and you don't want to tie yourself to an AWS service. So lots of good reasons to use Bedrock. I think actually on our website, we have a resource on when you might want to use Bedrock versus use a self-hosted solution. So if you DM me on LinkedIn, I can send you over that. And it's like a fairly good guide of when you might want to use one versus the other.
Okay, we'll take one more question just because pizza has arrived. So I know everybody wants to get some pizza. How do you self-host if you are a small shop or for individual projects? Where do you get GPUs from?
Great question. Well, if you don't have a good reason to self-host, and when I say good reason, I mean probably one of the ones I outlined, you probably shouldn't. So if you're an individual, then you're probably better off, and you're just doing this for fun, you're probably better off using something like OpenAI. However, if you want to self-host for the sake of self-hosting, you can use the consumer or like gaming GPUs. For example, like the 4090s are very, very good, 3090s as well. And you'll be able to self-host some actually fairly big language models on that. You also, if you have a MacBook, will be able to deploy some things on your MacBook. Probably won't be that fast, but it will be fun. And there's various open source libraries that help you do like MacBook deployments as well. if you're a small shop, think about why you're self-hosting. It's probably not because it's like more fun. And if you really, really have to, then you can use tools like, us. We have small clients as well as bigger clients as well, that make it a bit easier.
Okay, thank you very much, Meryem. Round of applause, please.
Thank you.
Thank you. Okay, we're going to have a 20-minute break now. So pizza's outside. Please come back for 7:30. Thank you very much. Okay, welcome everybody. Thank you for coming back. We're going to now have our second speakers of the evening. We have Rhea and we have Graziano. Please, a round of applause.
Hello, everyone. Can you hear me? Welcome. And do you enjoy the pizzas? I actually was forced by my colleagues here to dip my slice inside a sort of garlic sauce, and I probably lose my Italian citizenship after that. So let me know if it's easy to get the English one, because now I need another place to live. Okay. So stop joking. If you are asking why I'm wearing a hat, it's because I'm sick. So please be kind with me. And let's start. For the next 25 minutes, we will go to talk about platform engineering and its boundaries, just to see if, just to understand if there is room for something more, after the infrastructure side, the infrastructure provisioning. We are talking about platform engineering, so let's start with a couple of questions for the guys here live. Raise your hand if you are familiar with the topics like platform engineering, platforms, IDP, and something like that. Okay, and some of you already use an IDP, already adopt an IDP inside your organization. Okay, nice. I would like to start the presentation presenting this piece from the platform white paper by the platform working group of the CNCF. Maybe some of you already read it since they know the topic. And now, don't get me wrong, I'm not saying that what is written inside the white paper is wrong, and I'm not saying that the work done by the guy of the platform working group is wrong. I suggest you to read the entire white paper and to know more about the tag app delivery to stay updated about these topics. But if as you can see on the slide, I highlighted in red, most of the resources used in the white paper are related with infrastructure or DevOps. We are talking about databases, message queues, brokers, observability collectors, observability stack. And a question rises in my mind. We are sure that we can limit the world of platform just to the infrastructure side. Are we sure that we cannot extend the boundaries, the common boundaries we set to the platforms to get more value from them? Me and Rhea, we work in Mia Platform, which is a company that brings on the market an internal developer platform. So over the past years, we help many organizations to adopt an internal developer platform. And what we have seen is that three recurring steps, three recurring patterns can be observed inside this adoption process. The first one, of course, is the main goal that the companies have to adopt a platform, which is the self-service infrastructure automation. When a company enter the journey of platform adoption, typically starts with the goal of providing their developers a tool for self-service infrastructure. Maybe they already use Kubernetes as runtime environment, and they want to provide their developers with tools that can help them to get the environments they need in a self-service way without rely on a ticket-based system and wait that someone from the operational team creates the namespace or the cluster for them and to start to work. The second, what happened next? The platform is adopted by a large number of developers and starting become the central hub for all the developer works. So basically the value of the platform is recognized inside the organization and a shift occurs. We shift from a paradigm where the platform is a collector for self-service automation procedures to a paradigm where the platform is seen as a tool to increase the developer experience. And in this way, the organization starts build libraries, starts build templates, and starts build standards that the developers can use, and the automation procedures created before are integrated in a more larger paved path. Now, if I'm on a team that needs to start a new project, I just need to create it inside a platform. Just clicking a button or calling an API, it depends on the interface you have on your platform. You can have in few seconds all the stuff you need to start to work, from the repository for your code, from the configuration for your environments, all the boilerplate code for the chosen languages, and the libraries you need with all the connectors you need, and all the standards that the company define for you. This is a huge improvement in terms of developer experience, in terms of time saved by the developers, and this is also a huge improvement in terms of standards by the company, because doing so the developers are much faster doing their work, and the project are there all the projects are there to the same standards. So if the company define their standards for quality and their standards for security, all the new projects created inside the platform will adhere to them. Of course, in our initial phase, because then it's up to the developers, and we know how they are good to write tests and keep them updated, of course. Then the last step is when the platform reach its peak it reaches peak supporting the business. Here we are shift the paradigm from, in the first step, creating a set of procedures for self-service automation. Then we move to more complex paved path, and now we are talking about not more about procedures to automating something for a specific purpose, but we are talking about fully worked services and fully worked APIs that can be reused and composed together to create something new and more complex. Here is where the paradigm of composable architecture arises inside the platform, and here is where the platform become the collector of all the work inside the organization to let the users reuse something that is done by others and evolve it if needed. Okay. Based on our experience, we mapped with more details all this step in a map, which is this one. This is the platform journey map. Is a visual tool we created to foster conversation about platform strategy, and we use it to engage conversation with our customers to help them to assess the current status of their platform, and then trying to understand the priorities for the future. But here the point is not the tool itself. If you are interested in the tool, I'll leave a detailed article I wrote a couple of weeks ago, where I explain how we use it, and you can download the deck of slides to starting use it. But the point for the talk of the day is that, as you can see from the picture, we shift the focus from the tech excellence of the tool, the tech excellence of the platform, to the engineering excellence of the organization, the engineering excellence that the organization can achieve adopting and tailoring a platform over their needs. Okay. You can see the purple cells, which are the commonly recognized step in platform engineering, like environment as a service, powered roads, platform as a product, team topology, and the others. But this is just a part of the steps. We start thinking about the software delivery efficiency. We moved on talking about architectures. We talk about data. We moved on the composability side of our application, and then also to stuff that help us to tailor the platform to specific market use case for our organization. If the platform is the tool that we can use to deliver value, the fuel for the platform is the circular economy. What truly makes the difference is creating a circular economy inside of platform, where the platform become not just a place where value is created, but even a place where the value created by others can be reused by others team and even evolved based on their specific needs, and they can also contribute to this catalog, to this marketplace that enable this circular economy. Now, Rhea, can you explain us what we mean with circular economy using a simple example?
Thank you, Graziano. So to begin, let's actually understand what a platform is. A platform is not just a tool. It's a dynamic space where interactions and capabilities coexist. This coexistence is what allows users to actually leverage the platform to get the best possible results. Now, when it comes to these interactions that we're talking about, if we try to identify a few key roles, we can identify 3 key roles. That is of creators, consumers, and curators. Now, who are creators? Creators are basically users and their teams that work together to create tools, resources, features that all eventually become platform capabilities. Consumers, on the other hand, are users and their teams that use these different features and get access to these different features. And then curators is your platform team, who have the responsibility of overseeing and governing all of these things happening in the platform to make sure it aligns with your organizational goals and your overall mission. As you can also see here, there's a series of key steps: create, curate, share, discover, reuse, and compose. We're going to go through all of these in detail because these are all the key steps that take place in a circular economy. Now, coming back to what Graziano said, what exactly is a circular economy in the platform context? At its core, what a circular economy is basically a series of different features, different tools, different resources in your platform that can go through these multiple steps of creation, curation, sharing, to ensure that everyone that is using this platform is getting the most possible use out of it, and they're able to work in a virtuous cycle to continuously add on different benefits and gain those benefits back again. So now we're going to just get into an example. Let's start off with Team A. So Team A, just imagine, is a group of developers. They're all working on building a customer data management system. Now, when they start building this system, they run into a very common problem, which is how should they standardize access to all of the various databases in the organization? So now, instead of Team A just building a one-off solution that's going to help them in the moment, they decide to hunker down and all get together and build an abstraction layer, which allows them to convert these complex databases into clean, consistent APIs. What Team A has done here is, instead of thinking of a one-off solution that just works for them in that moment, they've thought of their solution as a reusable piece of code. With this, they're able to service other teams in their company as well, not just themselves. So this is what Team A has done. This is the create phase that we talked about. Enter the platform team. Now, the platform team is playing its role as curator. What the platform team sees in Team A's creation is more than just a solution to their problem. They see something that can be a compelling marketplace item. So while working towards curation, what the platform team does is they basically work with Team A to adapt the very team-specific solution that they created and standardize it so that it can be reused by multiple teams in the ecosystem. So this is the curate part of the circular economy. Once this code is standardized and is refined, the platform team creates this into a marketplace item. So this isn't just about putting a code on a repository. It isn't just about creating a marketplace item. It's about positioning this code in such a way that future teams see the value in it. And future teams are able to realize that using this will help them save a lot of time. So this is what happens in the share phase of the circular economy, what the platform team is doing by sharing this code onto the marketplace. Following that, we meet another team, Team B. Team B is dealing with a completely different problem. They need to integrate a third-party API and then also expose their data through an API. Now, what Team B would normally have done is they would have all come together to try to find a solution. They would have done research, spent weeks on building a solution for themselves, but instead they browse through the marketplace and they find Team A's solution that was curated and shared on the marketplace. So now when they test out Team A's solution, they realize that it takes care of about 80% of what they're looking for. It's a solution that covers 80% of what they need. So instead of taking all that time to create their own solution, they reuse Team A's solution. And they just spend a couple of hours customizing it for their own needs, which allows them to focus a lot more on their actual business logic, their unique business logic. So this shows us the discover phase, which is Team B discovering Team A's solution in the marketplace, and then also the reuse phase. Team B's reuse also validates the value of Team A's initial creation and the platform team's curation. Moving on, we look at Team C. Now, Team C has a very ambitious goal. They are trying to build a data discovery and governance platform. Now, what Team C does is they don't reuse Team A's solution. They take Team A's solution and they compose on top of it. So what does that mean? It means that they use Team A's solution as their foundational layer. To that, they add metadata capabilities, they add data lineage tracking, they add data quality monitoring, they add all of these different features. And in the end, the result of what they have is greater than the sum of all its parts. So basically, they've discovered Team A's solution and then they've composed on top of it, which takes us back to the curation phase and thus showing how a circular economy is working in the platform context. Now, the beauty of this model is basically that it's creating a self-reinforcing ecosystem. What this means is that each team is contributing to and benefiting from everything that they're doing and working together. What Team A did by creating something added a platform capability. What Team B did by reusing it showed that it was valid in the first place. What the platform team is doing is helping to curate these unique solutions that people can see have value. And what Team C is doing is completely creating its own composing its own new feature using the features of Team A. And eventually what Team C has created can go back to being a marketplace item like Team A's original composition, and then we can see how the circular economy is continuing. This is the true power of platform engineering, because you're creating an ecosystem which is self-reinforcing. It's a virtuous cycle, and each step that you do is helping you in your future steps. I'll hand back to Graziano to close off.
Thank you, Rhea, for explaining us the example of circular economy of software. Now that we understand what we mean with circular economy, let's see how a platform that supports this kind of approach looks like. So we have on one side all the stuff our engineers build, so the product of the company and all their application. And on the other side, we have all the dependencies the engineers need to leverage. So we could have infrastructure, we could have SaaS system and cloud providers, for example. And in the middle, there is our internal developer platform. In the common narration of the anatomy of a platform, we have two recognized capabilities. The first one is the infrastructure platform, and the second one is the DevOps platform. From Kubernetes environments to managing DevOps tools are very important capabilities for our platform, and as we already know. Then we, of course, need a portal which serves first as a centralization point for stuff like the documentation or the health metrics, access the dashboard, and so on. And then serves also as interface to interact with all the platform capabilities. And then we need also a platform orchestrator, which is the core component, the heart of the platform that powers all our capabilities. And till now is nothing new. It's like the platform anatomy that you can see, for example, on the CNCF platform white paper. In this vision, there is room for two other capabilities. The first one is the capabilities related to the data management. In modern products are not likely to succeed without data. So tools integrated in the platform to manage this data, like a data catalog, for example, to manage all the metadata about our datasets, or control planes to monitor and manage all the flows of our data, and even services to create our data fabric, for example, just inside the platform are a truly added benefit to our business. And the second one, the last capabilities, is the capabilities related to the stuff decomposability. Having services and components that help us to handle smoothly authentication, authorization for the services just inside the platform, or having services that help us to integrate our application easily with AI companion, for example, to create your own RAG system, your own chatbot, or integrate your app with the most known large language model. And or having, of course, the marketplace, the software catalog we are talking about before, to access all the stuff did by the other teams inside the organization, understand what they did and reuse it if you can, or evolve it if it doesn't adhere to your needs, or even tools that let you create your own micro front end and then orchestrate it right into the platform, or even managing events, for example, are an important step, an important capability of the platform that can be integrated to leverage all the possibilities we have with the platform and truly add to really create value for all the departments inside the company and the business itself. We reached the end of the presentation. Then we have some minutes for questions if you have them. And I want to leave you with this sentence that summarizes what we see today and what we mean when talking about platform. So platforms are a unified space for sharing value across all the departments of the organization, enabling efficient delivery at scale. And with adopting a platform, we want basically to turn all the complexity of continuous business evolution, not just about tool, but even about the market changes, for example, and the architectural complexity into something that can be managed with a platform and optimize the delivery. That's all for this presentation. Here you can find a feedback form if you want to leave us a feedback. Inside the feedback form, you will find also some in-depth material. The first link is an article that goes deeper with the concept of circular economy of software written by our CTO for the tag up delivery in September, I think. And then you can find also the contacts to know more about the tag up delivery and the working group platform for the CNCF, the CNCF platform maturity model and the white paper, and the article about the platform journey map we saw in the very first slide, and even our contacts if you want to add us on LinkedIn or contact us with mail. That's all. Thank you very much.
Questions? Just stop sharing your one. All right, we have time for just a couple of questions. Here we go. In the example on circular economy, how did Team A gain some value back, which will make it actually circular? How is this different from simply code reusing or inner sourcing in general?
So, you are, for me, you are thinking about in the wrong terms. You have to think about values in terms of the entire organization. So, is circular inside the organization. So, if someone does something today and then someone else can benefit from it, is the entire organization that benefit from this approach. Obviously, in this example, the team A doesn't get any value their work is made available to others. But if in the future the same team, the team A, need to do something and find something that can help them inside the software catalog, is a value also for them.
How would small organizations start with platform engineering?
It depends. There is not only one answer to this question, because first, I think that creating an internal developer platform for just one team, just one small team, is not affordable. And then you have to think about what you truly need, what is your starting point. So basically, for a small team, a platform can be just I don't know, a backstage instance that collect all the product delivered by the team and serves just as a governance tool. And when the organization, also the team evolves and a new member, then you can start thinking about in terms of orchestration, adding layer to manage infrastructure, adding layer to manage path, starting to think about standardization of the processes and something like that. So it depends basically on Your needs first, and then how much you can afford the initial expense to create your own platform or adopt it from one vendor, for example.
We'll take one more question because it's 8 o'clock. How do you deal with service dependencies, i.e. teams B and C are now dependent on team A?
How you deal with the service dependencies, team B and C, and now dependent on team A. Okay, this is the work on standardization done by the platform team, okay? Obviously, when the team A, for example, starts creating the abstraction layer to access the data, they are thinking and they are creating something that is valuable for them. Then when the work is standardized by the platform team is sandboxed to have less dependencies possible and be truly composable with other pieces from the marketplace.
Thank you very much. Round of applause, please, for Graziano and Rhea. Okay. Yeah, you can stop. Okay. That concludes us for the evening. A couple of quick announcements before we go. One, please remember to return these tags when you go out. Secondly, last time, apparently someone stole a pot plant. I don't know how to tell you, the pot plants are not part of the meetup. So apparently someone took a pot plant. Please return it if it was you, or please don't take it. I know. It's not part of the meetup, so please return the pot plant. We will be back again on the first Wednesday of every month. So I will see you hopefully in March. And we will go down now to the conductor, to the pub, and get some more drinks and hang out. So thank you very much, everyone. Have a good